how you doing? Joshua Armour here. I just want to first welcome you guys to the call. I'm here with the Blockchain Ecosystem Advisors and Provide, and we're going to go over smart contract best practices today and share with you guys how, we can pretty much look at different ways to work with a smart contract. And smart contracts, are very unique by design, and they're awesome. So one of the things we want to look for is how do we write smart contracts without too much logic or too much hassle? And, as Ethereum and other blockchains have evolved, many smart contracts have been upgraded or have been modified over time. And blockchain has matured in a sense where now we have best practices. So Provide is an awesome platform that allows you to build blockchain for DevOps and pretty much have a focus around being able to deploy your dApp or smart contract and being able to work with it. Today, we're just going to go over the logic of a smart contract, and I'm going to write a smart contract live for you here today and pretty much walk you through some of the best practices that you guys should take note of. So in this presentation, we're going to really cover a couple key things. So inside of this, we want to really focus on the evils of reentrancy. That's one of the biggest topics we're going to focus on today is reentrancy, what that looks like, and the evils that deals with reentrancy. We're also going to go over some smart contract techniques, things you should look out for when you're building and writing your smart contract. And lastly, tools for smart contracts. That way you guys can see some different tooling that's out there available now for you guys to work with smart contracts as well. So in this, we're going to really talk about, like I said, the evils of reentrancy. We're going to dive into some code here in a bit. And as I dive into that code, I want to be able to share with you guys, what are some of the evils of reentrancy? Like, what does that really look like? What does it look like to deal with a corrupt smart contract or vulnerabilities in your smart contract? That's going to be a very important aspect of this talk because a lot of security issues can happen when you are dealing with this, specifically around, being able to make sure that the wallet is the person that is receiving the crypto or the tokens or whatever transaction that is happening, and also making sure that it's going to the right parties, and then dealing with all of the different things that happen with that. We'll also go over tools for smart contracts. So the tools for smart contracts will also be a very, very important aspect of this as well, and the smart contract techniques. What I'm gonna do now is, since it's 12:06, let's jump right into the code. I have my IDE set up. I'm using Visual Studio Code for this presentation. And what I'm going to do is I'm going to pretty much work from the IDE most of the time. And what that would do is give you guys some indications and pretty much we'll be able to follow along. So here we have, some different smart contracts I wrote. But what I want to really focus on is what does it look like to deal with reentrancy? That's one of the biggest things that I really felt that was very important, because a lot of people don't understand what reentrancy is, and pretty much is when a person is sending a sending something from the balance of a wallet, the message.sender aspect of the smart contract can have a fallback function that you have to kind of protect. So what I want to do is pretty much get going and show you guys what that looks like. So when you're dealing with Solidity, you have to make sure that, you also understand that today we're working on Ethereum. Some people may know about Hyperledger. Some people may know about EOS and other platforms, but today we're really focused on Solidity. And in doing that, contracts with Ethereum have become pretty much the standard. So, what most people are used to are when they get into blockchain is they're really learning with not only Solidity, but the Ethereum ecosystem. So that's what we're going to focus here on today is what does reentrancy in a Solidity smart contract look like? So here I have a contract named payment. And inside of this, I want to set up a mapping from the address to an unsigned integer. And inside of this, I'm going to call this the owner balance. And then when this happens, I'm going to actually set up one function to get the balance. And this function is going to be very simple. It's just going to have an address with the owner name attached to it, and then we're going to set up a constant that returns the unsigned integer. Now, inside of this, we'll also have a quick return of the actual get balance. And in doing that, I want to be able to get the balance of the actual owner. And then close it out. And then moving that forward, I want to be able to also deal with another function, which is going to be to add to the balance of this. So this function will allow me to just pretty much make something payable. And when I do that, I can also pretty much get the owner balance again, and then pretty much set that up with a message.sender, and then add to this with a message.value, and then close that out. So with doing this right here, what we have is we have two functions primarily. One is to get the balance and one is to add to the balance. And then what we want to do after that is pretty much go right into the next part, which is to really kind of show you a withdrawal. And this withdrawal will pretty much have some basic logic as well. The withdrawal balance will also pretty much allow us to kind of see what this looks like. So inside of this, what I want to do is pretty much go after showing you guys one conditional, which would be if I am not the message.sender and it calls the value that we placed above, I want to be able to get the balance from that person in this function and then throw it and then close it out. And then what we're going to have here is outside of this throw, we're going to jump and dive into being able to see this owner balance inside of a message.sender. And then we're going to equate this to 0. Now, if you see what I'm doing here, pretty much this right here alone is an issue. This is what I mean by reentrancy, is that right here, this will have a fallback function. And that's a big issue that we want to avoid. And when doing something with a smart contract, we want to make sure that we don't have this issue at all. We want to make sure that we can deal with the smart contract and not have to worry about what I'm showing you right here. So in order to do that, what we have to actually do is set this up in a different way. So instead of actually, dealing with and the real issue is this right here, is that we're just setting it blindly. We're not actually setting up with any kind of state variable. And the state variable is one way to deal with a reentrancy. So when you have a way to, pretty much fix reentrancy, we can pretty much look at reentrancy as a way that a hacker or someone can pretty much, be on the back of a smart contract, and as it's being called, it can access that wallet as it's being called. So we want to be able to hold this stuff in state. So what I'm going to do is I'm going to comment out the code below. And what I'm going to do is I'm going to add a more proper function with a withdrawal that can show actually what is happening in a better instance. So here we have the same withdrawal function, but this time what I'm doing now is I'm going to actually set it up with a state variable. And a state variable is a way to deal with this. So when you are dealing with reentrancy, you always want to remember that, holding things in a variable is a great way to deal with the actual smart contract and the ability to withdraw something from it. So when I set it to an amount, I can set that amount to the owner balance as well, and then pretty much have it in a message.sender follow up. And then from there, we pretty much can say, okay, now let's take this actual amount from the owner, and then let's now set up to 0, because what is going to happen is is going to call that, and then again, now when I have it in this state, instead of it being in a raw state like you see here, we actually are holding it in the amount variable that we just assigned, and then we can set it up inside of this same if condition. But this time, instead, we're going to put inside of this the same logic, but we're going to call the amounts. And when we do that, we can pretty much guarantee ourselves that we have set up in a state variable so it's proper. So this way we know as we're dealing with the code and we're dealing with this state, we know we won't have to deal with any issues happening with reentrancy, because this alone will allow us to hold it out. And then that right there will give us some very key values so that we can pretty much hold it in the amount and call this if condition, and inside of it call the value amount so that it's stuck inside of that variable and it's held to that variable. Now, another way that is common as well to deal with reentrancy, which I'll do one more, and I'll do another withdrawal balance. And inside of this, what we want to do is, you take this out completely. What we'll do instead of this is we will set up another quick function, and inside of this function, we can then pretty much set up a withdrawal balance again. But this time when we do it, we can pretty much set it up with another call. And this call is a little bit more specific. This is a message.sender.transfer. So we can transfer the owner balance, right, to the message to the person receiving this, and also when they get it, they can pretty much know, hey, it's coming from the right source, because this transfer call is something standard that is used. You can use that or send, right? Either or will work. But here we're going to just stick with the transfer call, and all of this is in the Solidity documentation, which is helpful as well to be able to reference. And as you're doing this, you can work with the owner balance and then set up in a message.sender again, and then call it to 0. So here we have some very basic logic that shows, how to handle reentrancy and pretty much deal with a smart contract. For the sake of time, I'm going to move forward, but this was the first part that I want to really show you guys, which is really how to deal with a smart contract and how to work with Solidity. But more importantly, what we're going to do next is I'm going to actually write a more in-depth smart contract and we'll also talk through some of the stuff happening as I'm writing this new smart contract. So here we can take all this logic. I'll just add a new file. I'll put save. Save this real quick. Now, what I want to do in this time is I want to actually walk you guys through a more specific type of smart contract. This smart contract is going to be more along the lines of the technique of writing a smart contract. So the use case we're going to do today is a consumer purchase. So a lot of dApps deal with micropayments, and they also deal with people buying things remotely with crypto. So this smart contract is going to be pretty much for a purchase, and we'll pretty much title it a purchase contract. What I'm going to do is inside of this, I'm going to write everything out real quick and then put 0.5.1. Or better yet, instead of using that carrot top, we can actually assign it to any recent version of Solidity or older version up to 0.6.0, because that's the most recent one, right? And now with that being done, we can pretty much jump to the smart contract. So this smart contract will be called customer purchase. And inside of this, we're going to do some key things. First, we're going to set up some quick logic. We're going to set up an unsigned integer and then make it public and then call it value. Now we're going to have two parties in this transaction. One address is going to belong to a merchant, so we want to make this payable. And we also want to make sure that this is public so it's seen on the network. And then we're going to call this person a merchant, and this is the business owner. And then the second one is going to be the address that's payable via from the customer. And now we're going to focus on adding the state. So state is very important in a smart contract. You're typically going to deal with state a lot. So in this smart contract, we're going to have three states. One will be activate, another will be validate, then lastly we'll have deactivate. And with that being said, we can now have the state as a public state, and then we can close that out. Now, inside of the smart contract, we need to set up a constructor. The constructor will allow us to deal with different parts of the smart contract later. So we want to make sure that our constructor is public and is also payable so that this merchant can be dealt with. When dealing with a smart contract, we want to ensure that our values are set up right. So the merchant is going to be assigned to message.sender. And we close it out. And then the value will be associated to message.value. But we want to make sure it's divided by 2. The reason for this is because we want to make sure that our message.value is an even number. The reason for this is that it'll truncate if it's an odd number. So we want to make sure that, there's no odd numbers. We want to make sure it's even. Something we could get into later. And then we want to require that this is 2 times the value, and then that equals the actual message.value. And then we can close that out. So with that being done, we can now move on into showing you some real key things. One is a modifier. So a modifier really helps us deal with making sure that we can pause the smart contract if certain conditions are met, or deal with the logic as it's happening. So the first modifier will be a condition, and then this condition will be a Boolean value. And then we'll make sure in the condition that we have a require as well, and the require will have to execute. So we'll just put this require as the condition. It's already out there, so we're going to take this off, and boom, there we go, and then have that wrapped up. Now in the next part, we can put another modifier, and then this modifier will be for only the customer, right? Only the customer can do this purchase. So this way it has some restrictions on the smart contract. And inside of this, we'll put message.sender to the customer, and then close it out. And then what we want to do is pretty much make sure that only the customer can purchase this. So only the customer can purchase this. And there's a string, so we'll close out with 2 quotes, double quotes, and then we're going to add another modifier that is called only for the merchant. And inside of this, we'll have another require. So these modifiers act as a key way to hold in different types of restrictions to the smart contract, so we can make sure that the right parties are dealing with it. And another string will show, hey, merchant authorization only. And then we close that out, and then we can pretty much move on from here. And then we just want to add this as well to this logic. And then inside of this is another require. So we want to add this real quick. Now, moving forward, what we're going to do next is we're going to move into the rest of the smart contract. But first, we have to add one last modifier, which will be the in state. So pretty much if and when it's in state, when it's happening, when it's being executed, we can deal with it as well. And then we'll have that one last modifier to be able to require the state be equal to the state. And then out of this, it'll be invalid state if it's not this. And then we can close that out. So being done, we will now move forward to adding our functions. So before we add our functions, we need to deal with a few different events that are going to happen. The main event would be if everything is aborted. We want to call that. Outside of something being aborted, we want to deal with it if the purchase is confirmed. This is another event. So these would be our actual events happening. And then last, when the person receives it from their purchase, we want to make sure we have an item received. And then we can close out. So these are our events that will happen as the smart contract are getting executed. We can abort the purchase and reclaim the ether, God forbid. So if that happens, we need to actually write a function for that. So that'll be the main thing to keep in mind here as you're looking through some of these techniques. If we need to abort the function, we can pretty much do that by just setting it up with a public and then pretty much making it only merchant, as you've seen before. And then when we have that, it has to be in state. And I'm taking the logic from above, in state, and it has to be a state that is activated. So there's pretty much when you have the state that's activated, we can pretty much say, okay, this state is going to be the only way that they can deal with it, or if not, we have to kill it. We have to pretty much kill this transaction so that we can reclaim the ether and the contract is locked. So this is an abort function to deal with this smart contract. And then inside of this, we also might want to have one more thing, which is the ability to emit the actual abort function. And then that event above will be called. And then we'll have a state that equals state dot deactivate. And then we'll deactivate the smart contract, and then we'll take the customer and transfer their money back to the address and make sure that it goes to where it needs to go to. Then do a this.balance. So with all this being said, this is our first function that we just wrote. So as you can see with the logic, I'm going to slow down here and kind of go back. You can see that people that deal with smart contracts that pay for things with crypto, they have to deal with different things. And if I'm dealing with, let's say, a one-time purchase, I want to make sure that only certain people can access that. So we use 4 different modifiers to handle that. And with each one of these, we were able to add the logic based on the condition. The customer can be able to purchase it. Only the merchant is authorized to sell it, and it has to be in state. Or if not, when the state is being executed, it'd be an invalid state. And if we have to abort the smart contract, we just set up an abort function to be able to abort the smart contract if it's not the right customer. Now, with this being done, we can move into our next part. And if that's the next part of the smart contract, will be setting up a function for when a purchase is confirmed. So when we actually have the purchase, we actually confirm the purchase and say, okay, inside of this, we'll do another example of this and make it public, and then make it in state. And we want the state to be activated. And then when this happens, we're going to work with our condition from above, and that the message dot value is equal to 2 times the value. And the reason for this, again, as I mentioned, we want to make sure that it's an odd number. So that's why above here, we want to make sure that the actual balance is a even number. Sorry. The balance is an even number. And being able to do that allows us to make sure that, you know, we can avoid from truncating with the smart contract the actual balance of the Ether when a person buys something from their wallet. And with that being done, we can now pretty much make this payable. So that's the last part of this, is to make it payable so that the person can make sure that the payment goes through. And then what we'll do inside of this is another quick object, which would be to emit purchase confirmed from above, and then close that out, and then add the customer as the message dot sender, and then close it out again. And then we can create state and then make it state that someone has to validate. And when I say someone, I really mean that it happens and we want to validate it. And when we validate it, this condition has to be met. So this way, when the purchase is confirmed, we're making sure that the smart contract is not only created, the state is created, but that this condition is met when this function is executed in the smart contract. And then with that condition being met, then it's payable, and then the customer can send the money and it'll be valid. So that'll be very, very important. Now, with the last couple functions we want to add, we want to pretty much just set up some basic logic, which would be a function for confirm received, as you've seen above. And inside of this, we can pretty much do some quick things, which one of them making it public again, and then making sure it's only the merchant. And then inside of this, we will set up an end state again and set that up to state.activate. When we do that, this is the actual part that is very important. So when we have this set up, we also want to make sure that we do it in a way that is very, very important to have. Sorry, not be active. It's validate. So this end state will be state dot validate. So when we do this, we want to make sure that we have it set up so that we can deal with it. And after we deal with it, we're able to dive right into the next object, which is setting up the emit, making sure that the item is received. And when the item is received, this is what's going to happen. Now, if you remember before in this previously, I mentioned a transfer call that you can make, and that transfer call is pretty useful in a scenario like this. So we can pretty much put it as customer.transfer.value. And then with that, we can actually go and make the merchant get the transfer, and then set up with the address, set up with this, and then put dot balance. And then close it out. And then there you go. There you have it. So this is the actual smart contract. This portion of the smart contract is very important because we pretty much want to make sure that the item is received, and it's important to actually change the state first, because if not, then when the state is not changed, then otherwise the contract is using the send below will be able to call there again. So we want to make sure that we deactivate it. And we do that by making sure that it's deactivated. And the way we do that, like I said before, is when an item's actually received, we want to add that. So that's one thing that we actually have to do. That's very, very important, is to make sure that the state is deactivated so that we don't have to worry about it being called again. And then we wrap that up with the end of the smart contract. And with this now being done, we have the ability to know that this function is to confirm, is a confirmation that everything is received and that the item has been received. And this is very important because when we're dealing with the smart contract, so that way, when we have all this logic set up inside of it, the only merchant modifier that you see here above is utilized. The end state is constantly utilized. The actual condition is actually set up inside of the first confirm purchase, because that function is key to make sure that that condition is met. And then lastly, it is very important to make sure that we also deal with this as a whole. So let's take this code and then add it to Remix. So real quick, I'll add this to Remix. And now that you see the smart contract here, we can pretty much compile it. We can run it, and then we can deploy it. And then there you go. There you see it working. We can confirm it. So with that being done and said, we can pretty much know that the smart contract is something that's very important to keep in mind. And what I want to also show is what it looks like to actually work with some open source tooling for smart contracts, because that's the last part of this that we're really going to talk about. So we just went through the smart contract. Just to recap real quick. So one of the things that we had to make sure was dealt with was the ability to know that our smart contract had the address of the merchant, we had an address for the customer, and then we were able to deal with 3 different types of state. And when we dealt with these different types of state, we were able to make the state public, and inside of this set up a constructor with the merchant being assigned to a message.sender and having a value with a message.value. These things are concrete because it allows the merchant to receive or be able to send something. And then these conditions are important when dealing with smart contracts and customer payments to a merchant. So if you notice inside of the first modifier, outside of that, we have only the customer can purchase this. That was to obviously set up that modifier. That modifier is a technique. This is the technique here that we really want to pay attention to. These techniques can be used to really avoid a lot of different errors that could come from smart contracts. And like I mentioned, reentrancy is one of the main things we want to solve for around holding things in a state, in a variable specifically. And then when that is being executed, we're not dealing with outside people being able to sit there and wait until the contract is called and then have a fallback function to be able to, take any crypto out of a wallet. Now, these events are another example of techniques, but also events that you'll have to utilize when you may use this for a payment contract. So these events are dealing with the different life cycle. So this is the life cycle of the smart contract. You know, a purchase is confirmed, an item is received, or if not, it's aborted. So as you know, we set up an abort function with the merchant. And if not, we set up a confirmed purchase if the purchase is confirmed. And then inside of that, we made sure that we had the customer as the message.sender and the state is a valid state. And then when it's received as confirmed, that person was able to get the actual item and then also transfer the value from one wallet to another. Now, going back to our other scenario here, where we have the actual Open Zeppelin, like I showed you. This Open Zeppelin is an amazing tool to utilize for smart contracts. It is battle tested with 4.5 billion digital assets that are powered by Open Zeppelin. As you can see, some great projects use it, like Ethereum, Civic, Aragon Storage, a lot of great projects. And it runs on any version of Ethereum or eWASM compatible blockchain. And that's really important because a lot of the blockchain community is a fork or is built from the Ethereum architecture. So there's a lot of different things that happen when building a smart contract. And when you work with Open Zeppelin, it's a good thing to look at because it helps you to understand, that you can pretty much work with smart contracts, work inside of the smart contract code that they provide, and they really focus on security, which is important because you need to know that. And if you look behind the scenes, you can see Open Zeppelin is really big on making sure that they build open source infrastructure for us to deal with. And most importantly, they are big in audits. So this is one of the biggest tools I want to share with you guys for security, and is led by the Zeppelin team, which we appreciate them. So again, here, we want to also close this out with just highlighting Provide. And Provide is an awesome platform to really build and deploy your smart contracts. There are a couple of videos on our YouTube channel talking about how you can work with Provide. And we're chain agnostic, we're protocol agnostic. Everything is accessible through a REST API. And if you want to be able to just, pretty much work with our API, you can pretty much get going. And as you can see, you can work with everything from authenticating with a JSON web token to working with Goldmine, which allows you to access things from our API and get up and going. And then when you have the API in your arsenal, it really helps you have a tool that's something familiar for most developers. So again, this is Joshua Armour. I'm signing off. Thank you for watching. It's been an awesome time presenting for you guys today. Just live on the spot, dealing with smart contracts. And I look forward to seeing you next time. Thanks.